Hello, everyone, and welcome to another episode of the Futurum Tech Webcast. I'm your host, Ron Westfall, Research Director here at the Futurum Group. And in this episode, we're going to talk about the state of the global 5G market. We're going to talk about 5G Advanced, and we're going to talk about 5G standalone benefits, as well as the impact of key technologies such as AI, machine learning, and edge computing that is driving 5G innovation and so much more. Today, joining us is a most distinguished colleague and luminary in the 5G universe, Durga Malladi, the godfather of 5G. Good day, Durga. How's it going?
Good. Nice to see you again. It's been a while, Ron.
Wonderful. Yes. Yeah. Welcome back. And certainly we are most pleased. And thank you again for joining us. And Durga, please tell us about yourself and your role at Qualcomm.
First of all, thanks for having me on the show, Ron. Always enjoy these conversations. Uh, my I have taken on expanded set of responsibilities inside Qualcomm. My title is I'm a senior vice president and general manager for a newly created business unit called the Technology Planning and Edge Solutions. It spans all of the technology that we as Qualcomm create and bring to the market. This includes everything in connectivity, starting, of course, with 5G, Wi-Fi, Bluetooth, GNSS, and these days increasingly with SATCOM, satellite communications. That's in the connectivity bucket. Everything related to AI, our AI software tools, our AI software stack, specifically bringing in generative AI into the to the edge, into devices, and at the edge of the network. All of our processors, which power devices of all sorts, from IoT to automotive and handsets and compute segments somewhere in the middle, and XR devices. These processors are typically our CPU, GPU, and NPU based. All of our multimedia IP, so this is camera, audio, video at a very high level. Our software management that goes across all of our business units. And these days, in conjunction with AI, we talk about our data management and analytics platforms. So it's an expanded scope, and it's been about maybe 4 months or so since I officially took on this role, but really hitting the stride on this.
Wow, that's an impressive array of responsibilities. And I think that definitely is setting the foundation for framing our conversation today. And with that background, let's jump right in and start with our perspective on the status of the 5G market and its ongoing expansion globally. From your view, Durga, what do you think is driving 5G's planet-wide growth? For instance, what should folks understand about why 5G is gaining a greater foothold throughout the mobile and the digital ecosystems?
Good question, Ron. And it's important to actually understand the full landscape of where we are today, anywhere on the planet on 5G. It's the fifth year of 5G. If we start back in spring of 2019, when the initial launches were in US and Korea in the beginning, followed by Europe, Japan, and China. But if you take a snapshot of today, just in terms of where do we see 5G launches already occurring, in addition to those regions that we mentioned, other regions have started seeing a very large number of 5G deployments, 5G rollouts. These include a pretty gigantic market. In India, 5G launches after the spectrum was auctioned off earlier last year. The 5G launches began late last year. And one of the things that we're beginning to see is that if you are in the business of launching 5G today, would you start from where everyone else launched in 2019, which was what was called as the non-standalone mode, wherein you have both the usage of 4G and 5G networks radios concurrently? Or would you rather start with 5G standalone? And it so happened that one of the operators in India started off the bat with standalone mode. So that's a trend line that we are beginning to see. So in addition to India, in Middle East, in Southeast Asia, and in LATAM, There have been a large number of 5G launches since then. So this is just a baseline expansion of 5G footprint around the globe. The other part that we are seeing is we predicted this back in 2019 that over time there will be two sets of trend lines in the evolution of 5G topology. One is on the mobile broadband front, where we continuously see increased aggregation of spectrum in the low bands, the FTD bands, and the mid bands, TDD bands, in a very flexible mix and match of these spectrum assets, which means today's state of the art is around 4 to 5 carriers, state of the art, like the cutting edge devices today support 4 to 5 carriers getting aggregated at the same time. It gets a mix and match of a handful of TDD carriers and the rest of them as FTD carriers. The reason I stress upon that is it's not something that was not obvious, and it wasn't done quite that way during 4G days. It was towards the tail end of 4G that we began to see glimpses of it, but today we take it as table stakes. That's what is done in 5G today. It really gives an operator full flexibility. Bring in your FTD assets and TDD assets in sub-6 spectrum and put it all together. Similarly, the markets that launched with millimeter wave spectrum back in 2019 and 2020, there's still been a linear increase in the number of sites and regions where millimeter wave is being either deployed or being tested. So US and Japan take the lead in terms of millimeter wave deployments, but there were tons of trials to kick the tires and make sure that the technology works, especially with standalone millimeter wave. We saw a lot of that in China, and there are some trials that are ongoing in India and other parts of Southeast Asia and Middle East. So it's been a really good journey in terms of the expansion of 5G as a technology into the networks. As we also see proliferation of different kinds of devices. What started off with smartphones back in 2019, today you can actually walk into a store, you can get a smartphone which has 5G, of course, you can get a laptop that has inbuilt 5G. And if you want to have gigabit data rates directly to your home, and especially even on the uplink, if you want to have extremely high data rates, you have what is nowadays called as wireless fiber, the ability to use 5G for fixed wireless access and providing high-speed connectivity to residences, small businesses, and enterprises. These are the general themes and the kinds of devices that we've seen in the market today. Of course, there are IoT devices and automotive cars these days, which for the longest period of time were on 4G. We are beginning to see the initial adoption of 5G technologies into vehicles as well. It's probably been the fastest technology when it comes to this level of maturity in less than 5 years. I mean, if you just go back in time and look at all the other Gs, it's quite staggering and impressive.
Yeah, I find it encouraging. And that's an excellent level set and kickoff, Durga, in terms of setting the foundation for what is today's 5G market, what is the state of it. And I think what's also important is that it's triggering a couple of key thoughts. For example, the global expansion of 5G is key to providing a foundation for 5G to really, reach its ultimate full potential. And I believe it's important to address, the future of 5G as a result. For example, 5G advanced standards and capabilities that are going to be integral for 5G to fulfill, that potential. And so, Durga, can you tell us more about 5G advanced? And what is it that I think that our audience wants to know is what about 5G advanced and what it can bring to the overall 5G ecosystem, especially in the next 12 to 36 months?
Very important and good question. I'm going to spend some time in terms of what the current landscape and the trend lines are when it comes to these advanced features. So one of the releases that finished late last year, and we'll start seeing devices and networks coming up, with that 5G technology. It's called Release 17 of 5G. Formally speaking, it's not really 5G advanced, but it actually lays the foundation towards that, and it'll become quite apparent as I mentioned it. And for the first time since the first two releases of 5G, this will be the third release, Release 17. There are two themes over here. The first theme is about continuous evolution of features that we already know. So there will still be continuous evolutions and enhancements of different ways of performing MIMO, providing coverage enhancements, power consumption reduction in devices and in the networks, different sorts of protocols and procedures in place to do that. So that's a continuous evolution of what we have already done, fine-tuning it a little bit more, but it's more incremental evolution as opposed to something drastically different. So that's like one bucket of features. The second bucket of features is actually a little bit of a throwback, and it's called as reduced capability. And this is an important one. Reduced capability of devices, or RedCap as it is called, is really thinking of it as you should think of it as a 5G Lite. It's a lighter version of 5G. Instead of 100 megahertz, 200 and 300 megahertz capability in devices going up to 10 gigabits per second, which stretches the envelope, it's actually going the other way around, where instead of very large bandwidths, you go all the way down to 20 megahertz, and you actually don't use 4 receive antennas, but 2 receive antennas, 1 to 2 receive antennas. So sometimes it's even 1. And the peak data rates are about 100 to 200 megabits per second, which, by the way, is plenty already. I mean, we talk of gigabits per second all the time, but this reduced cap or red cap based devices will form the foundation for proliferation of 5G at the lowest tier. This would be the true democratization of 5G adoption in devices that historically we would think of as low-end devices, very cost-sensitive, but it's also great for mass adoption. And in those device categories, the cost matters. The data rates are not as important, but connectivity is extremely important. And there are other KPIs that matter. Power consumption could be a little more latency tolerant and so on. So think of water meters, gas meters, going on to smaller form factor devices, whether it's industrial robots or effectively it's good enough connectivity, 100 to 200 megabits per second. But at the same time, it's in a different segment of device price points altogether. So it's at a true democratization in that sense. And these devices will eventually become important even in, or this technology will become important even in more cutting edge devices, but of the smaller form factor, like XR devices. Imagine if you want to eventually wear glasses with an embedded 5G modem inside. These are the kinds of technical elements that will actually play a role. So RedCap therefore has a huge potential, and we're just getting started. And mind you, there's plenty of consumers who will be more than happy taking that 100 megabits per second and saying that's good enough for my fixed wireless access. Who's to say that you need a gigabit connectivity all the time? So there is always a segment where you can even use it for basic broadband connectivity as well. Important segment. So that's like the second pillar, if you will. The third one actually goes the in a way that's it's also kind of retro in the sense that satellite communications in the last 2 years have suddenly become very popular. And the popularity is not because of the fact that it's satellite communications. That's always existed for a very long time. But the fact that you can now perform communications through satellites using your regular devices. Take your regular handset. Nothing new, nothing that's really bulky, not a new device of any kind, but you use your existing smartphone as an example, your existing laptop, if you will, and you're connected via satellite to anywhere in the world. And this is really an important segment which started off with basic emergency services using your smartphone, but it has legs as we go beyond that into providing connectivity, very low data rate connectivity for IoT devices, which literally could be in the middle of nowhere, but there's no terrestrial network that covers it. So it's an easy way of doing that. So imagine you have some sort of maybe a windmill farm that's located out in the middle of nowhere. You want basic connectivity, just monitoring the health of that system, then you would have that. Similarly, some sort of an oil or a gas pipeline, you just want basic telemetry coming up from there. So SATCOM actually there is extremely important. As you go beyond that, so we talked about RedCap and SATCOM. The other part that's increasingly coming up is the idea of improving positioning technologies, because something that we don't usually take, think through very carefully uh, is positioning always based upon GNSS and the answer, or GPS? And the answer is no. Increasingly, we use terrestrial signals complementing GPS and all the other constellations in the world. So improvements in terms of positioning and positioning accuracy is a fourth pillar where there's a lot of emphasis. And in this case, the holy grail is to get towards centimeter level accuracy, both indoor and outdoor, and preferably by also knowing not just where you are in terms of lat and long location, but also in terms of the height. So for instance, I'm in my building, and if I tell you I'm in this building, it's not good enough for you. You might say, well, which floor? So that's like the third axis, the Z axis, that becomes important. So these are the themes that we are seeing in release 17. And as we go further, so release 18 is the true 5G advanced moniker as denoted by 3GPP. It expands upon all of this. Taking that satellite communications, which is for low data rates, well, why stop at low data rates? Why can't we do voice and video and add more capabilities on top of that? That's the next thing. And in addition to expansion in terms of the SATCOM capability, a couple of other themes that come in are really trying to think about where does cellular technology go as we pay attention to other happenings in the tech sector. So for instance, there's a lot of buzz associated, and we'll get to that, a lot of buzz associated with AI. What are the techniques from AI that we can start bringing into cellular so we have the next generation of air interface, perhaps as we head towards 6G direction, but in the next generation of air interface, what techniques from AI should start coming in as a part of the standardization process? Because you don't have to standardize everything, but there are some things which would be helpful to standardize. Further, a more efficient way of using spectrum is to use what is known as full duplex, wherein you're using the same spectrum for both transmit and receive. Well, we do that for TDD today, but full duplex would actually mean that you're using it concurrently. That has all sorts of other techniques. Well, how do you make sure that you're transmitting and receiving in exactly the same band at the same time? Those are the studies that have started as a part of 5G advanced evolution going beyond that. The formal work as a part of 5G Advanced will therefore go in the direction improvements in energy savings in the networks. It's an important aspect for most operators as they measure their own carbon footprint and say how much energy am I consuming as a part of 5G networks, and of course in devices, but certainly on 5G networks. Better ways of providing coverage with smart repeaters, improvements in broadcast technology as we start taking a renewed look at what new services we can bring in with broadcast. But one underlying theme, as I mentioned this, is for all of this, we truly need 5G standalone. Like we have to jettison the non-standalone and move towards 5G standalone. Not because you cannot do it with non-standalone mode, it just makes it so much simpler to start doing this with standalone mode and having that core network, which is like a clean slate that brings in the best features of 5G.
Yeah, that's essentially true from my view. And I think the four pillars are a key takeaway for anybody who is a decision maker in the 5G ecosystem and the 5G realm. And I think that one thing that is also going to be important is that 5G Advanced fully aligns, as you pointed out, Durga, to advancing the sustainability goals of the CSPs as well as any other supplier out there in terms of meeting strategic objectives that are being increasingly required and measured by governments, across the world. And that's, I think, an excellent segue. The fact that 5G Advanced naturally needs 5G Standalone as a precursor, a harbinger for making sure that the adoption of 5G Advanced is smoother and all the more successful. And so to shift over a little bit From your view, what are the immediate benefits of 5G standalone implementations? And where are we seeing these 5G standalone benefits today?
So 5G standalone, just to get to the basics of it, uses both 5G radios and a brand new core network that brings in new features in a far more elegant manner. So let's start with one of the features that's quite popular these days with the operator community, and that's called network slicing. Network slicing, in the simplest possible way, is the ability to map any application to a specific what is called as a slice and provide it with a very different quality of service compared to some of the other applications. Now, you might think, well, that sounds a lot like regular QoS. We've done that in 3G, we've done that in 4G. So what's new? What's so different about slicing? Well, during 3G days, I would argue that we would basically say there are two kinds of services. There's voice and there's everything else. And so that was like a very, I know it's a very simplistic way of putting it, but it actually kind of cuts to the chase of this is what it is. In 4G, we were a little more nuanced and we talked about this voice, then there's video, which is a combination of multiple things, but clearly data driven. And then there are other services, which are things like web browsing and so on. And this was like a QoS or quality of service centric view of what you could do. Some of the other ones are more subtle, but equally important. Uh, from a device standpoint, if you go to the lowest end of the devices, instead of simultaneously running two radios, which is what non-standalone mode would be, because you do have to light up both 4G and 5G radios, now you only are either in 4G or in 5G mode, but not simultaneously at the same time, which reduces the total number of components that are needed. The software stack footprint gets smaller. It effectively makes those low-end devices far more prolific. And so that actually democratizes, again, what I mentioned earlier, in terms of adoption of 5G in the lowest tier. So that actually helps quite a bit there. Other services include the ability to provide, uh, you know, uh, in addition to the quality of service, the way to bring in the mix and match of TDD and FTD carriers, and tomorrow with millimeter wave also thrown in. It just so turns out it's much more easier when we do it through standalone mode. It's a more subtle technical point, but it does make it extremely attractive. If you also take a look at even from millimeter wave and the usage of millimeter wave for fixed wireless access, from an operator standpoint, one could start thinking in terms of using millimeter wave only, no sub-6 associated with it, just millimeter wave, to provide fixed wireless access services. So you kind of use that spectrum only for one service, so that you can actually then focus on, for smartphones, you can use a mix and match of sub-6 and millimeter wave, but for one of the other services, you only focus on millimeter wave. So there's a lot of flexibility that's provided with standalone mode. And that's the reason why pretty much every operator in the world, he has either taken steps already in the direction of migration to 5G standalone, if not already started deploying 5G standalone.
Yeah, I think it's key. I think we've seen, the information out there that about 22% of the operators that have invested in 5G have implemented 5G standalone. And so the good news is that number will go up. It's inevitable. And that, I think, will make a big difference in terms of, how users and customers will all the more adopt and perceive 5G overall. And another thing that I think is going to be a major factor is, and you touched on it already, Durga, is the role that some emerging technologies, those that can be, I think, viewed as disruptive, are going to have on 5G. And that, I think, includes AI, machine learning, and edge computing. And that's going to definitely, I think, influence the evolution of 5G. Certainly 5G standalone, but 5G advanced and overall. So Durga, from your view, how do you see AI, ML, and edge computing driving new 5G capabilities and innovation in key areas such as better speeds, improved energy efficiency, location accuracy, link robustness, and mobility, to name a few. What do you see down the road?
This is a topic that's near and dear to my heart. The
Mhm.
confluence of AI and 5G coming together, there's so much potential involved in this. AI has improved every single technical segment that it has entered with image processing, with voice processing, and now as we take a look at cellular, as Qualcomm, we decided we don't have to necessarily wait for standardization of the technology or adoption of AI into 5G standards in one formal way or the other, but we embraced it from a long time back. And starting from last year, we started bringing in AI based technology embedded into our 5G modem RF platforms. So our very first announcement in this segment was with what we called as our X70 platform. This was early last year at Mobile World Congress. We made our announcement with the first generation of features that we brought in. It's exactly along the lines of improvements in terms of the device throughput and the user experience. And then this year, we went one step further and we made our announcement of a dedicated AI tensor accelerator embedded. It's a hardware block that's embedded within our modem RF platforms. That shows our commitment towards that as we bring in new capabilities, improvement in location fixes, improvements in beamforming, the way you hold your smartphone and the way you can actually latch onto either millimeter wave beams, and therefore actually have a much better experience compared to what you had before. Even previously, we thought it was pretty good till we saw the further improvements that we can bring in using AI techniques. So we've already started that journey. And as we kind of look forward, uh, when we talk of 5G advanced, laying that foundation for AI-based techniques into cellular, it goes one step further and says, well, in addition to what every device and network will probably do just by proprietary implementations, are there protocols that we need to develop so that the devices and the networks exchange information with each other and are able to train and do the inference of all of these, AI models that are emerging? So it's a fascinating field, as you can imagine. From Qualcomm standpoint, we are extremely active in this space, in standards and in our research domain. So stay tuned on that front. When it comes to edge
Yeah,
computing, there is one just to mention the part on the network side. There is a separate trend line on the networks, which is about increasing the virtualization of the radio access network. So virtualization of RAN by running software on third-party hardware allows you to run multiple workloads at the edge of the network. So today, at the edge of the network, what we would call as a base station, but typically it would be a DU, distributed unit, where the baseband processing is being done. If you take a hard look inside the server where the processing is done, one can easily say, well, maybe that same edge, the server that's there, should be in a position to run both the RAN workloads and AI workloads. So you have edge computing workloads running concurrently. And that brings in a different dimension for mobile operators who can now start thinking of providing additional services beyond data services to consumers. So it's a truly fascinating field in that sense.
yeah, I think it's definitely a great perspective you provided, Durga. I think that it's tying together, what about the other key technology trends and how that can definitely improve 5G capabilities, not just from the standards, which are always important, but also in terms of driving that innovation that we touched on. And certainly, I believe on-device AI is going to be integral to that. And certainly in terms of enabling distributed workloads that allow AI to actually develop in a way that is ethical, in a way that is going to actually meet immediate demands for the enterprises and the consumers out there. And on that high note, thank you so much, Durga, for coming on and sharing your insights and thoughts, always most valuable, and also ensuring that we know what Qualcomm's perspective is on the topmost developments in terms of what's going on in the 5G ecosystem, including 5G advanced, 5G standalone, and again, those key technology trends of AI, machine learning, and edge computing. And with that, everyone, thank you for joining us today and have a great 5G day. Thank you
Thank
so much. And thank you, Durga.